All right, guys, we're going to start looking at the graphs of the sine and cosine because I really think the best way of understanding this is by looking at your graphs, okay? Now, I know this chart might be a little confusing, so I will try to, explain this and hopefully you follow along and we'll get some other explanations for you going as well, okay? So, previously we learned that the sine is the y value. The sine is the y value. Okay, so the y value as I move counterclockwise around the unit circle is the segment in red here. Okay, so the y value here at 0 degrees is 0. And my graph that's being plotted out in red is the graph of the sine. So when I'm at 90 degrees, my sine value is at 1. And my graph has a peaked out value at 1. Okay? And so when I'm at 180 degrees, my y value is back to 0. Okay? So my graph has an intercept right there. Okay? When I'm down here at 270 degrees, my y value is back to 1, and my graph is at -1. I should have said -1. And then I'm back, okay? So let's follow this along, okay? Sine graph is being generated. Sine starts out at 0 because there's no red height there. There's no height, okay? At 30 degrees, we know that the sine of 30 degrees is 1/2. So my sine graph rises to a unit, 1/2 unit in height, okay? When I'm at uh, 90 degrees, my sine value, my y value is at 1. So therefore, I'm reaching my height right there, okay? At um, at 150, I'm back to a sine value of 150 is 1/2. So my sine curve is at a height of 1/2 at 150 degrees rotation. My sine value hits 0 at 180, as you can see. So the sine graph crosses the axes at 180. All right, moving around, my sine is going to reach, okay, its lowest value. The y value is going to reach its lowest of -1 down here at 270 degrees, as we can see plotted over here on the red graph, okay? And then when I'm back to 360 degrees, I've completed one revolution, okay? And I've completed what's called one cycle of my sine graph. If I wanted to go through another revolution, okay, my sine graph would just run through another, what we call another period, okay? So we're going to identify things over here, okay? From 0 to 360 degrees, okay, is one revolution or one wavelength, okay? One revolution, one wavelength, okay? Actually, one wavelength could be from any high point to the corresponding next high point. Now, this graph doesn't show you. We'll show you some other ones that do, okay? And that would be 360 degrees, okay? Things to notice. We know that the sine was positive in the first two quadrants because the sine value, all study trig carefully, is positive, and my graph, as you can see, is above the x-axis in those two quadrants, okay? We also knew that the sine was negative in quadrant 3, and it's also negative in quadrant 4, okay? And therefore, you can see that the sine graph dips below the axes at those values, okay? Let's talk about the cosine graph. Let's talk about the cosine graph. The cosine graph, okay, is following the x coordinate of this point as we move around the unit circle. It's following the x coordinate as we move around the unit circle. Now the x coordinate is indicated by the length here in blue. The length here of this triangle is the x coordinate. When we start at 0 degrees, my x coordinate is at its highest value of 1, okay? My x coordinate at 90 degrees is at 0. and therefore, okay, my cosine graph crosses the x-axis, has the x-intercept there, okay? At 180 degrees, my x-coordinate is at -1, okay? My x-coordinate is at -1, and my graph has its lowest point in the uh, in of -1, okay? When I'm back to 270 degrees, my x-coordinate is shrunken down to 0, so I have another x-intercept there, okay? And then I come around 360 degrees, it brings me right back to the starting point, my high point on the graph, okay? This high point from 0 to 360 degrees is one period, one revolution, which is 360 degrees. Okay, if I wanted to continue that another revolution, I would generate another wavelength. Okay, these are what we call periodic functions. They just keep repeating themselves over and over and over again. Okay, but everything we need to understand about the graph is displayed here in just going one revolution. It's going to take on all the values it will ever take on simply going in one revolution. Okay, so if we talk about the domain of the function, the domain is actually infinite because this graph will just keep generating itself. If we go negative, okay, we're going to generate negative graphs, and in the negative uh, angle values. We'll show you that later. The range, well, the range is simply, okay, the range is simply from -1 to 1. So it lives in a very small world between -1 and 1. That's the entire range of the sine function as well as the cosine function. Okay, now I'm going to post a um, couple other videos that would show this unwrapping of the sine and cosine function, and we'll talk more of it. I'll put some other videos together for you and talk more about it. Again, looking at the cosine. Okay, we look at the cosine. We're looking at the blue graph here. We're looking at the blue length of the triangle. Okay, and we can see we're in quadrant 1 where the cosine is positive. Okay, at 90 degrees, the x-coordinate, the cosine is 0, so we have an intercept, okay? The cosine in quadrant 2, as we know, is negative, so the graph is negative, all right? Okay? The cosine is also negative in quadrant 3, so the graph over here between 180 and 270 degrees is going to stay negative, okay? When we reach quadrant 4, our cosine is positive, so we're graphing the cosine. You're following the movement along the blue axis, the blue graph over here, coming up towards our highest value of 1. If you're wondering about um, the, the, the green graph, that's the tangent graph, we'll have a lot more to say about that later, but what you can say is that, okay, the tangent graph has these asymptotes because the tangent is the sine over the cosine. So going angle for angle is the value in red divided by the value um, in blue. So at 0 degrees, my value in red, the sine, is 0. The value in blue, the cosine, is 1. So 0 over 1 is 0. Uh, when I get to 90 degrees, okay, my blue value is, okay, at 0. Uh, I mean, my red value, the sine graph, is at 1. My blue value, the cosine, is at 0. 1 over 0 is division is actually undefined, but okay, the undefined nature is actually imposing an asymptote. So, in fact, we say 0 divided by 1, or I'm sorry, 1 divided by 0 is going to be infinity. And we'll have more to say about that tangent graph there, okay? So there you have the graphs of the sine and the cosine. As I said, I'll show you some other items coming down the line, okay? Sorry, and there's our values of the that we know are familiar to us, our familiar stops along the way, okay? Uh, which we saw earlier in our earlier presentation. Okay, there you have it.